Hello, I'm Karandeep.
I'm Dan.
I'm Donald,
I'm Carmine.
and we are working on a revolutionary shopping cart, and I will start with the background of the project.
And then I'll take it into the house of quality and the specifications we used.
I'll carry it off into the kinematic analysis and the stress analysis.
I will talk about the CAD and the FEA.
And then we'll be done.
The team finds out that moving and lifting heavy objects can produce challenges to disabled or elderly people in the retail industry. After investigation, we also think the repeating process in transferring bulky objects may tax on individuals' body. Unintended cart damage to vehicles and theft are the common issues besides producing potential lifting injury. The team gathered the information of the existing shopping carts and added the enhanced performance to the project cart for further analysis.
Once we determined that there was room for improvement, the next step was to decide where to concentrate our efforts. We expanded our list of customers to include not just the people using the cart, but employees and other shoppers as well. A quick poll of the elderly and able-bodied people we know presented us with some avenues to pursue. We saw that size compatibility with existing carts was important, and while current power carts do well with moving through the store, getting things in, and especially out of the basket and into vehicles was a common complaint. Therefore, our first focus became ease of load transfer. We looked into force standards for hand-controlled vehicles and settled on a maximum force of 100 newtons. Then we saw that existing power carts often don't carry enough, so obviously size needed to be looked at. Finally, powered carts often don't maneuver as well as the unpowered types, so that became another area of concentration. On our own, we decided that stability and theft resistance would be important too. So here's what we started with, but some of the details changed as we went along.
We perform analysis on the following components of the proposed shopping cart: the lift gate, the lead screws, and the mast and its junctions. The movement of the lift gate is constrained by a single pin joint on one end of the gate, joining the gate to the cart basket. The clockwise or counterclockwise movement of the gate by the motor determines whether it would be open or closed. The lead screw mechanism in our design is powered by a motor as well. With the press of a button, the motor rotates the lead screw clockwise or counterclockwise, raising or lowering the holding basket. The following methods of failure of the lead screw were analyzed: buckling, static failure, and fatigue failure. A safety factor of 4 was targeted against buckling. Calculations show a lead screw with 10 mm diameter needs to be used. The shear and torsional stress analysis yielded a factor of safety of 24.1 and 11.8 respectively. The endurance limit was found to be 112 megapascals, which is well above the stresses on the threads. Therefore, the screws are adequate for infinite life. The torque and power required to raise the cart was found to be 6.8 Newton meters and about half a horsepower, which can be achieved by a simple cordless drill motor. An electromagnetic brake has also been implemented since ball screws are not self-locking. And shear stress calculations for the basket supports were also performed. The joint where the cart basket joins the mast was analyzed to give a factor of safety of 1.98. Further, the FEA helps us conclude that the remainder of the structure has relatively low stresses.
For our design, the length is 0.76 meter, width is 0.63 meter, height is about 1 meter. The maximum of change in height is about 0.75 meter. The vertical movement of the cart is determined by the lead screw position. The motors and ruler will control the lift gate and belt. User can control the horizontal movement through an onboard controller. The maximum loading is 2500 Newton. The FEA shows von Mises stresses on the weight-bearing component of the shopping cart assembly. There are about 1250 Newton in each ruler. For our design, the total cost of the cart is about $1,871.